These are notes from Elham's Math 60 for Wednesday, May the 6th, doing section 10.3, page 885, on something called the hyperbola. A quick word, skip problems 33 and 35 in our homework. 33 and 35 we're throwing out. What does a hyperbola look like? It's either going to look something like this. It goes to left or right, or it goes up and down. As you can see, some of these, this one goes left and right, this one goes up and down. For a hyperbola, the equation looks almost the same as the ellipse, except there's a minus sign. You might recall from the other day for the ellipse, there was a plus sign here. If this is a minus, you have a hyperbola. So x squared over a squared minus y squared over b squared equals 1 is a standard form for a hyperbola. If x comes first, x is positive, y is negative, then it opens left and right. Now, they might give it to you with the y squared first. So y squared over a squared minus x squared over b squared equals 1. Then it's going to go up or down. Quick word that's a little bit tricky here. If y squared comes first, even though we're putting a squared here, a still determines how much you go vertically, not horizontally. You look at the letter that's right above here. And in this situation, b tells you how much you go in the x direction. It's a little bit tricky because you're used to seeing the x come first for all the ellipses and half the hyperbolas. So you just have to remember that this a, in this particular case, tells you how much you go up and down because the y is first. Alright, so here's how you do the hyperbola. A lot of it is the same as the ellipse, but some of it is different. X squared over 9 minus y squared over 4 equals 1 for problem 17. Since x is positive and y is negative, I know it's going to go left and right. Okay. Alright, so I determined my a and b, sort of like the ellipse. A is the square root of 9, which is 3. B is the square root of 4, which is 2. So it starts off like the ellipse. So if we're centered at the origin, which we are in this case, because it's not something like this where you're adding or subtracting something, you go 3 to the left and 3 to the right, 2 up and 2 down. So if this were a plus and this were an ellipse problem, I would take these 1, 2, 3, 4 points and just draw my ellipse. However, it's a hyperbola, so there's a lot more work. So I take these 1, 2, 3, 4 points here and I draw myself a box. Okay, so I draw horizontal and vertical line segments to draw the box, and then I connect the diagonals, so the diagonals will go through the center. Alright, and then I determine which way the hyperbola goes. Since I already know it's the horizontal type, I take these 2 points here and just curve it toward the green lines, which are called asymptotes. Fancy word, asymptotes, A-S-Y-M-P-T-O-T-E. You don't have to memorize that. Those are lines which the graph approaches. It gets really, really, really close to the asymptotes, but it doesn't quite touch it. All right, now if the hyperbola had been vertical, I would take these 2 points here and curve it toward the asymptotes, and you'll see that in another example that I will do later on. Okay, the problem's finished. Just to emphasize, the stuff that I have in red is the actual hyperbola. That's what I'm indicating in red here. The box is not part of the hyperbola. The green asymptotes are not part of the hyperbola. The actual hyperbola is the stuff in red. And I also want to emphasize, these two combined are considered one hyperbola. We don't say that there's two hyperbolas. In other words, you don't say this is one hyperbola, there's another hyperbola. They're disconnected, but that whole thing is considered one hyperbola. Here's problem 21. It starts off with y squared minus 4x squared equals 16. You might recall, just for the ellipse also, I'm supposed to have a 1 on the right-hand side. They give me a 16, so I, in red, divide both sides by 16 to get a 1. So this is y squared over 16 minus x squared over 4 equals 1. All right, since y came first, I know it's going to be an up and down type of hyperbola. Okay, so a is the square root of 16, which is 4. B is the square root of 4, which is 2. However, 4 is going to be vertical. Again, it's associated with y. So from my origin, I go 4 up and down, and 2 left and right. So I have these 1, 2, 3, 4 points. Again, if this had been an ellipse problem, I would just take these 4 points and just curve them. But instead, I have to draw myself a box. So go straight up and down and straight across, vertical and horizontal line segments. Connect the two diagonals, which will go through the center. All right, so if x squared would have come first, just like the previous problem, I would take these 2 points and curve them toward the asymptotes. However, I know this is going to be up and down, so I take this point and just curve it toward the asymptotes. And that's the problem 21. Alright, starting with 25, we're not centered at the origin, we're centered somewhere else. So here's x minus 2 squared over 9 minus y squared over 16 equals 1. So the center this time is 2, 0. Again, change that sign. Or you can ask yourself, what number would I plug into x to make this expression 0? That would be 2. This one, just leave it as 0, or you can pretend it's y minus 0. Okay, and since x came first, I know it's going to be something like this, the horizontal type of hyperbola. Alright, so a is the square root of 9, which is 3. B is the square root of 16, which is 4. So from my center, which is not necessarily the origin, this time the center is at 2, 0. I go 3 to the left, 3 to the right, which I'm indicating with a 3, 4 up and 4 down. Draw myself my box. Connect the two diagonals, which would go through the center. And then determine which way it's supposed to go. I already know it's the horizontal type because x came first. So I take these 2 points right here, curve them toward the asymptote. You get really close to the asymptote, but you don't quite touch it. Okay? Again, if this had been a vertical type, I would take this point and just curve them toward the asymptote. Here's 27, where y is first. So since y is first, y is positive, x is negative, I know it's going to be the up and down type of hyperbola. Y plus 1 squared over 1 minus x minus 2 squared over 4 is equal to 1. So a is 1, b is 2. The center is 2, negative 1. It's a little bit tricky, even though they write y first. The way we always write points is x before y. So change the sign of x, 2. Change the sign of y, negative 1. So 2, negative 1 is over here. Alright, the square root of 1 is 1. That's how much I go in the vertical direction. So 1 up, 1 down from the center. B is 2, so 2 to the left, 2 to the right. Again, if this were an ellipse problem, I would just take these 1, 2, 3, 4 points and just draw my ellipse. But since it's a hyperbola, I draw myself a box instead. So take these 4 points, go straight up, across, connect the diagonals, which will touch the center. And if this is a vertical type of hyperbola, I take these 2 points and curve them toward the asymptote. So you can see this particular case, the hyperbola goes quite wide. It's a lot wider than, let's say, this one. This one was quite narrow. It's just the way the asymptotes either gives you a lot of breathing room or it's all scrunched in this kind of situation. Here's 31. Y minus 3 squared over 25 minus x squared over 25 equals 1. Once again, y is first, so it's going to be a vertical type of hyperbola. And in this particular case, a and b are equal. A is 5, b is 5. You might recall for the ellipse, if there was a plus, if these were both 25, you actually have a circle. Here you're still going to have a hyperbola. The only difference is that your box is going to be a square. So the center is 0, 3. This is like x minus 0, which is just x. So c is 0. The y coordinate is 3. So here's 0, 3. And now I go 5 units every way. 5 to the left, 5 to the right, 5 up, 5 down. Draw my box, which in this particular case is going to be a square. Connect the diagonals, which will be my asymptotes. And since y came first, I know it's the vertical type. So I take this point and curve them toward the asymptote. So the problem's finished, but if x came first, then I would take this point and curve it toward the asymptotes. It would be the horizontal type of hyperbola. Here's one more, problem 39. X squared over 4 minus y minus 1 squared over 9 equals 1. X is positive, y is negative, so I know it's going to be the horizontal type of hyperbola. So the center is 0, 1. Remember, change this sign here. A is the square root of 4, which is 2. B is the square root of 9, which is 3. So the center is 0, 1. From 0, 1, I go 2 to the left, 2 to the right, 3 up, 3 down, which I'm indicating in green here with the 2, 2, and 3, 3. Draw myself my box. Connect the two diagonals, my asymptotes, and my graph will get real close to those lines. And since it's a horizontal type of hyperbola, I take this point and curve them toward the asymptotes. Again, if y had come first, I would take this point and curve them toward the asymptotes. But as it stands, that's the answer that we want in this particular case. So this is the hyperbola. This is for Melham's Math 60 for Wednesday, May the 6th, section 10.3, page 885. There's only one more section in the entire book that we're covering, 10.4, and we'll do that tomorrow. And the exam will not be Friday this time, it'll be next Monday for the exam for Chapter 10.